We haven't had this much Starbase news in quite some time. Starship's 9th flight took to the skies, progressing to SECO, but not much further beyond. Furthermore, Elon Musk took to the stage in the Star Factory with SpaceX's 2026 Mars plan. Tons of details about the next generation Super Heavy booster, including hot stage hardware, and much more. We're looking to the future in this Starbase update. Of course, it was launch week, so let's focus on that first, the 9th integrated flight test of Starship. On the eve of the launch, we observed activities quite typical of launch preparations. Not only did the detonation suppression system have a brief run with water visible beneath the pad, but we also saw testing of the grid fins on the booster and the flaps on the ship. These tests would be conducted again during the final countdown, although SpaceX usually carries them out as part of their final checks the day prior to launch as well. During the launch preparations, our team also brought something back we haven't seen in quite some time, KiteCam V2. It still needs some development, but we're always trying to bring you the best views possible. It also helps to put the vehicle into perspective a little bit better. The launch itself came about on Tuesday. After initially closing around the vehicle to protect it from some poor weather, the chopsticks opened up to get into launch position. The tank farm and related bits of infrastructure started puffing and venting quite early in the morning, but everything really got going about 3 hours before launch when it was time to start loading propellant. After 2 brief pauses in the countdown, holding at T-40 seconds where SpaceX was sorting out a problem with one of the booster's Raptor engines, they pressed on with the launch and Super Heavy fired up. All 33 engines ran successfully during the ascent, and by all accounts that part of the flight was absolutely spot on. When we reached hot staging, the tweak SpaceX made on the new vent blocks on the hot staging ring was very apparent. The booster didn't just flip in any old direction, instead it tilted upwards away from the ship as the ship ignited its 3 sea level and 3 vacuum optimized Raptors. Up to that point, everything looked straight down the middle. Let's focus on Booster 14's mission first. It was, of course, not only flying for a second time, marking the first booster reuse in the Starship program, but it was also tackling a rather steep re-entry angle, with tests planned right through to the tail end of the landing burn. It did manage to reach the ignition for that landing burn, but only just. The very moment we saw the Raptors light up was the same moment the booster was lost. Now we're venturing into proper speculation territory here, but given the booster's very steep angle of attack, it's possible the Raptors or the booster's overall structure took a battering during that experiment, leaving them unable to properly ignite and carry out the landing burn. Curiously, it looked like all 3 center engines fired up, even though SpaceX was aiming to simulate the landing with 1 center engine out, though that might only apply to the final 3 engine burn phase of the flight. Either way, we'll likely never know for sure, as Booster 14 was lost, raining booster parts into the Gulf within the predefined hazard zones. Shifting our focus to Ship 35, it was of course the primary highlight of this flight, especially considering that the 2 previous ship burns had gone pear-shaped for different reasons, the first due to harmonic resonance and the second because of a Raptor hardware failure. This time though, it actually made it to SECO, ship engine cutoff. There was some flames spotted in the engine section and a hotspot cropped up again on one of the Raptor engines, but we had our fingers crossed and it pulled through. SECO was achieved for the first time with a V2 Starship. To celebrate this milestone, we've got some cracking SECO celebratory designs available on the NSF store. All of this coverage, all of the cameras are only possible because you, the audience, back us through the merch store, and we genuinely mean that. So if you want to help us keep doing what we do for plenty more flights, pop over to shop.nasaspaceflight.com and pick up something as a thank you for your support. We've also got a few more Flight 9 patches up for grabs, but remember, when they're gone forever. We don't reorder another batch in. Alright, back to the ship. Shortly after SECO, things took a turn for the worse as the vehicle started to show some rotation. Due to a leak potentially related to this bright glow on the aft skirt just after the sea level Raptors shut down, SpaceX lost tank pressure, which is critical for firing the ship's cold gas thrusters. Without attitude control, the ship couldn't get into the proper orientation to fight the plasma during re-entry, meaning it was effectively the end of controlled flight. It also meant that, without proper attitude control, the ship would have to forego the Raptor relight test. SpaceX probably didn't want to risk igniting a Raptor when the vehicle was spinning out of control. Therefore, they began to automatically safe the vehicle by venting all remaining pressure. Before that planned Raptor relight, though, was another objective which failed to be achieved. The payload bay door, which was meant to open to release the Starlink boilerplate satellites, ran into a problem preventing it from opening, meaning those little pretend Starlinks were stuck inside Ship 35. SpaceX is the only organization in the history of spaceflight to build and fly a Methalox full-flow staged combustion cycle engine, and they can't open a door. And so, without meeting any of the coast phase test objectives, once the plasma started to form and once the ship hit the thicker parts of the atmosphere, it wasn't belly first, but more sideways first. Ship 35 survived long enough to beam back some onboard views of the engine section being engulfed in plasma, but the stainless steel body couldn't hold up to the thermal regime of re-entry, so it was lost shortly after at approximately T plus 46 minutes. So where does this leave us with flight feedback? It's a bit of a mixed bag, to be honest. The ship finally reaching SECO is a great milestone, and the booster was put through its paces with those experiments. But all in all, it feels like SpaceX were hoping for a tad more from the whole affair. With 3 flights in, and the heat shield department still hasn't gotten any useful data from the new and improved layout incorporated into the Block 2 upper stage. The big news of the week, which is kind of scary to say considering we just had the 9th flight test of the most powerful rocket ever manufactured, was that Elon Musk gave another presentation to a group of SpaceX employees. Originally, this was meant to be broadcast live prior to the launch, however, for whatever reason, it was delayed until after the launch and then cancelled entirely. Luckily, SpaceX recorded it and released it at a later date. Following a brief introductory video showcasing the progress from the initial flight tests, Elon went on to start the presentation. This presentation covered everything we wished to know and receive updates on, from ships, boosters, vehicle plans, and even SpaceX's Mars plan for the next few years, including sending 5 Starships to Mars next year, but more on that later. On the topic of production rate, Elon states that the current facility could produce a next-generation Starship approximately every fortnight to every 3 weeks. He then notes that they aren't doing so at present as they're still refining designs and iterating. Honestly, looking at the past few months, this claim doesn't seem far-fetched, and one could imagine it being true in a scenario where they repeatedly build the exact same ship design. But if you reckon that's impressive, the facility's aim, apparently, is to produce 1,000 ships annually, or roughly 3 per day. This would mean rolling out a ship every 8 hours or so, multiple workstations working so efficiently that they can churn out a ship that frequently. This, of course, is very much a long-term vision and would require Starships designed to be stable. For this production rate, the Gigabay is a required facility. It's specifically noted as the building enabling the production of 1,000 Starships per year. In the render provided, the Gigabay has 2 big doors facing Highway 4, so that does at least make it a little bit realistic to peek inside when SpaceX opens them up. This is, of course, still just a render, but it could very well become reality. Following the infrastructure chat, Elon moved on to the Starship vehicles, specifically the reuse of vehicles. Of course, the booster has already achieved reusability, but what about the ship? Regarding the ship, we were shown a new render. Curiously, the render of the ship appears to still be a Block 2 ship, which in this case is landing on Pad B as we've been expecting. In the render, the ship executes a sort of small roll while performing the belly flop, which seems to be a rather unique maneuver. It would then be oriented with the tiles facing away from the tower. In the background of this animation, a booster is also visible, having been caught on Pad A. This entire scenario feels very much in line with what we'd anticipate from the Block 2 ships and boosters. Alongside this animation, the SpaceX CEO said that they hope to achieve this feat in 2 or 3 months from now. This timeline could, of course, have been affected by the recent setback on Flight 9, but it still suggests that it would involve one of the remaining Block 2 ships, rather than Ship 39 or beyond, which would be a Block 3 design. We then received some wonderful updates on Raptor 3. This included a clear image of 2 Raptor 3s, serial number 8 and serial number 6. SN8 is a vacuum-optimized engine, while SN6 is a sea-level engine. They're positioned in front of an army of Raptor 2 engines, with serial numbers reaching as high as 540. A single Raptor 3 saves 1 ton of vehicle mass, amounting to 39 tons across the entire vehicle. That is a substantial mass reduction. Elon then noted that the Raptor 3 will remove the need for basic heat shielding on the bottom of the booster, as the engine is designed to shield itself, eliminating the need for that that additional hardware. He further mentioned that this makes hot gas and plasma leaks easier to manage as they no longer build up in a confined, smaller space. If SpaceX can actually pull that off, that would be mighty impressive. SpaceX clearly watched last week's Starbase update, where we expressed our desire for the first up-close video of a Raptor 3 test at McGregor, and well, they delivered. Alongside this test, we were treated to some awesome statistics. SpaceX has conducted over 300 engine tests, totaling more than 16,000 seconds of runtime. Based on our daily monitoring over on McGregor Live 24/7, this chart seems either quite dated or rather conservative, as we've tallied around 500 tests with over 30,000 seconds of firing time. It's possible we're mistakenly counting some Raptor 2 tests as Raptor 3, while we know certain test bays at McGregor no longer support Raptor 2, others are less clear. Or the PowerPoint just hasn't been updated in some time. Elon Musk then moved on to discuss propellant transfer, which is a critical component of Starship's architecture to, reach places beyond low Earth orbit. Once again, the render depicts a side-mounted docking, which is what we expected. Naturally, there have been various designs in the past for how Starships would dock, but this appears to be the preferred method, at least until, SpaceX changes their mind again. In the render, the active docking ship seems to have active pins that connect to the passive docking ship, 2 on the LOX tank and 2 on the methane tank, totaling 4 hard connections. Both ships will use the non-tiled side for docking. If you recall back to April of last year, we heard quite a bit about this from a NASA update, and we covered it in a Starbase update episode at the time. Back then, NASA stated that the Starship propellant docking system would be a probe and drogue style, which we can now finally see in these renders. The unfortunate bit is that while last year the propellant transfer demonstration was slated for 2025, this test is no longer planned for this year and is now scheduled for 2026. One issue that SpaceX will encounter in the future is the high oxygen density in the CO2 plasma on Mars, which means that the heat shield faces twice the atomic oxygen during a Mars entry compared to Earth. Why does that matter? Well, because oxygen is an oxidizer. It could cause the heat shield to burn up even faster than on Earth. As a result, SpaceX has rigorously tested the current heat shield in a CO2 plasma jet at the University of Illinois. Elon also acknowledges that perfecting the heat shield could take a few years, as it's an extraordinarily complex problem to tackle. SpaceX aims to use the same heat shield for both Earth and Mars, allowing Earth to serve as a testbed for Mars, meaning there won't be a specialized Mars heat shield for the ships. The talk then moved on to a render of a next-generation Super Heavy booster. This would be a booster like Booster 18, which is currently under construction. It still has 33 Raptor engines, confirming our assumptions for that booster, even though the regulatory paperwork still allows for a 35-engine booster. One significant change with the next generation of boosters is the shift from 4 to 3 grid fins. However, the 3 grid fins won't be arranged in a perfectly symmetrical 120 degree apart orientation. Instead, they'll be configured in a T-shape. Regrettably, Elon didn't think to acknowledge this change, so we're left to speculate a bit. Based on some of his earlier comments from years ago, it seems this change could simplify booster control by using the 2 grid fins positioned 180 degrees apart for roll and pitch control. The 3rd grid fin could then act as a sort of rudder to manage the yaw of the booster. I'll be honest, I'm starting to get a little bit annoyed about how aerodynamics keeps going, you can't do that actually at every step of this vehicle's design. First it was the ship forward flaps, now they're coming for the grid fins. What else is big aerodynamics going to take away from us? Next up, the elephant literally in the room, the hot staging ring. The entire talk was delivered in front of a section of the new hot staging interface, although it's unclear whether this is for Booster 18, another booster, or even a test tank. The ring is integrated onto a few barrels and features numerous diagonal struts connected to the ship mounting ring on top. In the center is a robust dome, which could either be a protective dome or the methane tank's forward dome itself, significantly reinforced. There doesn't appear to be a second dome below it for now, so we'll have to wait and see how the final design takes shape and whether it will include 1 dome or 2. This design would eliminate the removable hot staging ring, making it a single integrated component. This, in turn, means the entire stack will be reusable, leaving only the commodities to be discarded. This new design is giving off some serious Soviet rocket vibes. In terms of size, the booster is increasing from approximately 69 meters to 72.3 meters, with a propellant capacity of 3,650 metric tons and a liftoff thrust of 80.8 meganewtons. This means the thrust per Raptor engine at liftoff will be nearly 2.5 meganewtons. Another change visible here is the exposed engine section, as the booster will no longer need heat shielding for the engines as discussed earlier, but it will instead have some heat shielding at the bottom to protect against the plasma flow. You can see a black protective coating around the very bottom section of the booster. Regarding the ship, we got confirmation of what was already assumed. The ship will retain 6 engines, at least for now. The figures for the ship's size are a bit perplexing though, as the slide for Flight 9 quotes the height of Block 1 ships. The Block 2 ships currently flying are actually 52.1 meters tall, matching those stated for Block 3. So either someone muddled the numbers or the ship size will remain unchanged for Block 3. However, on another slide, it says that Block 3 ships will have a propellant capacity of 1,550 tons, roughly 50 tons more than the Block 2 ship, which adds to the confusion. As expected, the ship retains 15.7 meganewtons of thrust, consistent with the figures provided last year for Block 2 ships. With the changes to the booster and ship, the entire stack will now carry approximately 5,200 tons of propellant, up from roughly 4,900 tons overall. The stack will grow slightly from 123.1 meters on Flight 9 to 124.4 meters for Block 3. Note that this is the exact same stack height we were given in 2024 when Elon presented Starship version 2. So when will this next-gen vehicle fly? According to Elon, we'll see these launched by the end of the year. This aligns rather well with the current production status of Ship 39 and Booster 18. Many of us reckoned it might be closer to early next year, but reality is surprisingly in line with Elon time. Naturally, further updates are planned for the future, and here Elon presents a future Starship, possibly a Block 4 of sorts or even beyond. This would increase the booster's height by nearly 10 meters to 81 meters and the ship to 61 meters, resulting in a total stack height of 142 meters. This is slightly shorter than the stretched variant shown in the 2024 presentation, perhaps indicating that some of these future variants are no longer vague concepts and are becoming more refined and studied. The future generation Starship, Block 4 or whatever you want to call it, would also increase the number of Raptor vacuum engines to 6, bringing the total engine count for the entire rocket to 42. As Elon noted, 42 is, as ever, the answer to everything. This also confirms that SpaceX appears to have no plans to alter the Super Heavy's engine count in the near or mid-term future, as some might have speculated. It seems it will remain at 33 for now. Of course, Elon has one clear objective for why he wants all of this development to take place, and for those who've seen numerous Elon presentations, this will come as no surprise. The SpaceX CEO spoke to how the company intends to establish a self-sustaining city on Mars, and how this immense capability is essential to achieving exactly that. Again, there's nothing particularly novel here at first, as we've heard the Mars discussion before, but in this presentation he delves into much greater detail. Naturally, launch windows to Mars are limited, and only every 26 months does the Delta V cost make a transfer viable. Delta V is the change in velocity required for an in-space maneuver. The next window opens in the November of 2026. Elon states that SpaceX has a 50-50 chance of meeting that window because they still need to sort out orbital refueling. But if they manage that, and they're prepared on time, he's got a plan. In the updated Mars architecture, SpaceX aims to land 5 Starships on Mars, which are launched during the 2026 window, each carrying 10 tons of payload. The primary goal here would be to demonstrate the capability to land on Mars and to maximize what can be learned from these missions. In the following window, that number would rise to 20 landers, each with a payload of 75 tons. This phase would involve delivering initial infrastructure to Mars, verifying essential resources, and preparing additional landing sites. Tesla's Optimus robot plays a significant role in these early uncrewed missions, serving as the initial workforce on the Red Planet. These flights would then scale up further in 2030, and by 2033, the plan is to send as many as 500 landers, each carrying 300 tons of payload. Of course, it's an extremely ambitious plan, perhaps more of a dream than a near-term reality. But regardless, they're giving it a proper go, and if there's one company who could pull it off, it's SpaceX. SpaceX has even investigated potential landing sites, with one candidate being the Arcadia region on Mars. Arcadia Planitia is a relatively smooth plain suspected of containing subsurface ice, making it a prime location for such a landing. For those of you who have been following SpaceX for well over a decade at this point, this location may ring a distant bell, as it was also discussed with the now cancelled Red Dragon mission. As a communications network for Mars, SpaceX proposes a Martian Starlink network, which, unsurprisingly, would provide an independent planetary network on Mars, with the potential to relay signals back to Earth. Of course, this doesn't eliminate the communications delay. The Earth-Mars lag would still be about 3 minutes at best, and considerably longer at worst. You cannot go faster than the speed of light. However, it would at least establish a relay capability for the Red Planet, which currently only exists in a limited form. Eventually, all the big tech companies are going to end up establishing data centers on or orbiting Mars, because waiting up to 22 minutes for a web page to load simply won't be acceptable in the modern universe. But the fact we're already at the stage of discussing how we can watch YouTube videos on Mars is pretty extraordinary. One day in the future, huge fiber lines similar to the underwater oceanic cables we have here on Earth may end up sprawling around Mars, but for a start, Starlink ain't bad. One more point before the presentation came to a close, we caught a glimpse of some landing leg renders in a shot where a Starship is being transported on a Martian SPMT. So if you thought the good old self-propelled modular transporters were going out of fashion anytime soon, think again. Wherever SpaceX goes, SPMTs will be rolling right behind. That was quite a hefty amount of information, especially in the middle, and it was much more insightful than I was initially expecting. Of course, only time will tell as to how it all develops. Now, let's turn our attention to the upcoming vehicles that are currently being built to bring this vision to life. Let's hear from the chief designer himself. Musk mentions that going forward, the launch cadence for the next 3 flights will pick up pace, roughly one every 3 to 4 weeks. That's quite an interesting figure, as he specifically says next 3 flights, which, by coincidence, also matches the number of remaining Block 2 ships, Ship 36, Ship 37 and Ship 38. It appears SpaceX plans to adopt a fairly brisk launch rate for these final Block 2 ships, before taking a brief pause to prepare for Block 3. Alongside these, there are 3 matching boosters, Booster 15-2, Booster 16 and Booster 17, and we already know which booster is set to fly next. Thanks to SpaceX engineer Shana Diaz, who shared a detailed post on X confirming that the next flight will use Booster 16, so we're not getting a Booster 15 reflight just yet. However, Diaz also confirmed that the next flight will once again feature a catch attempt back at the tower. I'm very happy about that. Regarding the timeline, she says, quote, "I'm optimistic based on what we're seeing in the data that the turnaround time to Flight 10 will be faster than it was for Flight 9. We need to review the data to confirm all fixes from Flight 8 worked as expected, but all evidence points to a new failure mode." So let's consider what that means for the timeline and whether Elon Musk's estimate of 3 to 4 weeks is realistic. And well, honestly, the timeline isn't that far-fetched. Dare I even say that Elon time, just this once, might be realistic? Of course, this assumes everything goes smoothly during testing, as predicting problems is always quite difficult. But looking at Ship 35, it completed its 6-engine static fire on the 12th of May, with an initial launch date at that time set for the 20th of May. That slipped, of course, due to the engine replacement, but even from the final test, the spin prime, SpaceX took just 6 days to get the ship ready. To our knowledge, Ship 36 is already receiving engines or has them installed, so there's a good chance it will roll out to masses sometime next week. That would leave plenty of time for the static fire. Booster 16, meanwhile, was tested in March with a round of cryogenic proof testing, and based on the testing schedule of Booster 15, it's entirely realistic that it'll be ready for a static fire around now. This means that the only realistic thing that could delay a 3 to 4 week turnaround is how long Flight 9's leak problem takes to fix. SpaceX will still be reviewing the data, so I doubt they have a perfect fix just yet. Another potential issue for the 3 to 4 week turnaround that might arise is the mishap investigation recently opened into to Flight 9. The Federal Aviation Administration must sign off on the SpaceX-led report into the problems that occurred during the flight. The good news is that the mishap is quite limited in scope. The investigation focuses solely on the loss of the ship, which did not complete its mission profile as planned, given the whole losing attitude control and flipping and burning thing. The FAA has determined that the loss of the Super Heavy booster is covered by one of the approved test-induced damage exceptions requested by SpaceX for certain flight events and system components. The FAA evaluated each exception prior to launch approval and confirmed they met public safety requirements. It is expected that this process might proceed quickly once SpaceX fully understands what went wrong, but it remains another factor that could add a few days to the timeline if SpaceX submits the report late. Before we turn to the Block 3 vehicles, it's worth a quick mention that Ship 37, currently slated for Flight 11, rolled out to Massey's on Thursday in preparation for cryogenic testing. That testing began just a day later, and we saw some kind of multi-hour combined cryo test of Ship 37, so the pace certainly isn't slowing down. SpaceX is really committed to this high cadence approach for the time being. Looking at Booster 18 and Ship 39, which are currently the expected vehicles for the first Block 3 stack, we know Booster 18 is actively being stacked inside Mega Bay 1. The ship might be the trickier part, as they're still stacking Ship 38 in Mega Bay 2. Of course, Ship 39 is already in pre-production, but ships take quite some time to prepare, especially with the heat shield, so keeping an eye on Ship 39's assembly process could be crucial for gauging when the first Block 3 flight will happen. One more item to touch on this week is Pad B, which of course is required for those Block 3 vehicles to launch. SpaceX has been working to install the first of 2 expected booster quick disconnects, which, combined, will feed the Super Heavy with its liquid methane, liquid oxygen, and other commodities. Fingers crossed SpaceX makes good progress on this item over the next week. Will the first Block 3 vehicle launch this year from this very pad? Let us know what you think. For now though, I've been Caton for NSF, thanks for watching, and goodbye.